Here we go. All right. Guys, quiet, please. Thank you. So let me read the blurb here, and then we'll go through the story. You have developed several strategies for solving equations and systems of equations. You have also focused on the meaning of a solution. In this lesson, you have the opportunity to see how your strategies can be used in everyday context. We're doing word problems. That's what's happening here. You'll expand your understanding of solutions by applying them to these situations. As you work today, use the questions that help stimulate mathematical conversations. How can we model the situation with equations? So let me kind of explain what these things mean, these questions, put a more layman's term for you guys. So how can we model the situation with equations? So basically, how do you set up the word problem? That's probably the biggest challenge, I'd say, that students usually struggle. That's why students don't like word problems, because they don't know how to set it up. How do you set up the word problem? What does the solution tell us? So basically, what real life implication is there? Because there's a real life implication sometimes with these word problems. How can we solve it? So which technique will you use to solve it? We do something algebraic, we graphically, or even algebraic, we do substitution, elimination. And there are any other strategies that could be useful? Graphical, perhaps. So that's what those questions mean. In layman's term, that's what they mean. But the first one's the most important one. How the heck do you set it up? Because when you give me an equation, it's going to solve it, you guys are fine. You guys just do it, right? You're not a problem. But sometimes come with the equation, and even before the equation, maybe knowing what the variables are. What are you trying to figure out? How many variables you need? What should you make the variables, right? Those are things that we're going to work on today. Okay, so let's look at this story here. I guess I'll give you guys another copy. Sorry. Okay, so Brady and Alex were still eating lunch, and they came to Algebra 2 class. Someone left the book on the floor, and both tripped. As they hit the floor, the food they were carrying went flying across the room directly toward Trevor, who was showing off his latest dance moves. Okay, that's kind of silly. All right, anyway, as they're watching in horror, Brady's cupcake and Alex's sandwich splatted right on top of Trevor's head. Brady's cupcake flew in a path that would have landed on the floor 20 feet away from him if it had not hit Trevor. Alex's flew in a path that would have landed on the floor 24 feet away if it had not hit Trevor. Brady's cupcake flew 9 feet high, while Alex's flew 6 feet high. So how tall is Trevor? Blah, blah, blah. Okay, there's a lot of fluff in these problems. Okay, so really, this is why this is the big takeaway here. There's a lot of, I like to call noise. In this word problem. Do I care that they're watching horror? No. Do I care that it hit in the head? No. What do I care about? I care about the numbers. That's it. And also what type of equation or modeling we're going to do here. Looks like it's going to be like a parabola, right? So I'd probably say you're going to want something that's parabolic. You probably want parabola equations, right? Also, I want the numbers, right? That's what I care about. So Brady, 20 feet and 9 feet high. That's Brady, right? And there's a different color highlight for Alex. Alex, 24 feet and 6 feet high. Okay. So let's make equations for both, right? So and I try to color code this best I could. So for Alex, that's a little thin. Let me make that a little thicker. There we go. For Alex, now remember the equation, parabola equations are like this, right? We know this. And if we think about graphically what's happening with Brady, it does this, right? So what would be the x-intercepts for Brady? Obviously, we're starting at 0. What would be the other x-intercept? 20, totally. And what would be the coordinates of the vertex for Brady? 9 would be the y coordinate. What would the x coordinate be? Perfect, because you split the middle, right? So let's come up with an equation now. Y would equal a x minus blank squared plus blank. What would I put in the blanks for Brady? So what would h and k be for Brady, given the situation I just drew? X minus what, guys? What's h here? 10. Take a component. Perfect, 10. And what about for the k? Plus what? Plus 9. Perfect. So let me write out more neatly. A x minus 10 squared plus 9. However, we're not out of the woods yet. We got to figure out a. How would I? What was that? How do I figure out a? So how would I solve it? What would I do? Yeah, plug in. So we could do plug in 0, 20, because that's another point that you know. So 20 equals a. You could plug in 0, 0 also. That would have worked just fine. 20 equals 100a plus 9. If you solve for a, you should get. Hold on, did I make a mistake? I made a mistake, guys. What mistake did I make? Yeah, but for this one, I actually should. It was 20 comma 0, guys. Sorry, my bad. Or 0, 0. Let's do 0, 0. That's easier. So my apologies, guys. I goofed there. So negative 9 equals 100a. A is negative 9 out of 100. So that's your equation for Brady. Brady's equation is clearly negative 9. Sorry, y equals negative 9 over 100. X minus 10 squared plus 9. Okay. And it said that they both hit him on the head, right? Okay. So definitely hit him somewhere. Now let's do Alex. Okay, so I ran out of space here, so let me do Alex somewhere else. Actually, let me do you guys have all the information? Can I erase the bottom part? Yeah. Okay. Let me erase that. Let us do Alex. Okay, for Alex, it's gonna look like this, right? So what's the x-intercept here, guys? 0 and what? For Alex? 24. How high does it go? 6. And of course, that would be a 12, right? Alrighty. So I'm guessing Trevor's probably less than 6 feet tall. If it does hit him. Oh, I'm sorry. No. He's probably at least 6 feet tall. I take it back. Wait, no. Hold on. Give me a sec here. I'm not sure yet, actually. We'll come back to that. Okay, let's make the equation. Sorry, I'm just I'm goofing here. Okay. Now, what do I plug in for H and K, guys?
12 and 6.
Good. Perfect. Thank you, Jack. Okay, how do I solve for A? Yeah, 0 is just probably easier. I like that better, you know. So you get negative 6 equals 144A. A is negative 6 or 144. So Alex's equation, which I'll do right here, will be y equals negative 6 over 1. I could reduce it, but I'm not going to. You'll see it's just not necessary. And that's plus 6. Okay. All right, so now we got both equations. All right, so does that make sense how I made the equations? We're okay with that? Using stuff that we've done before, right? We've made equations with parabolas. It's nothing new. You guys know this, right? We're all good. All right. And you guys actually don't need your laptops open. Can you lower your laptops, please? Thanks. Yeah. And Jeff, you too. You don't need a laptop open. All right. Yeah, we're pretty low tech today. Okay. So we're good on that. Okay. Now, what am I going to do with those equations? Because think about it. They both throw food, right? Do the food items meet at the same time? Well, not meet at the same time, but do they hit the same targets? They hit the same target, right? Yeah, maybe they don't hit at the same time, but they hit the same target, right? So they intersect. These two curves have to intersect. Oh, go ahead. Yeah, go ahead. Yes, 100%. You are 100% correct. We set them equal to each other. Thank you. That's 100% correct. I know it's a very long-winded word problem. I wouldn't write a word problem like this on a test because there's a lot of fluff, but you have to filter out the noise. Focus on the numbers and what type of formulas we're doing with. These are parabolas, right? I'll show you right now. Let's do it right now. So this is going to be a little, the algebra is actually a little crazy. I actually don't like the algebra for this because the numbers are really nasty here.
Most problems gonna look like that.
I don't know yet. On the homework, let me look. I don't know. Yes, Ben, go ahead. Yeah, go. Sure, yeah, go ahead. No problem. All right, so here's what we're going to do, guys. You're going to send them equal to each other. So you're going to solve by substitution. So here we go. I'm going to have -9 out of 100 times x minus 10 squared plus 9. Oh boy. -6, 144, x minus 12 squared plus 6. Okay. Solving this is going to be a total pain because of the fractions. I would never do this to you guys on a test. I would never say solve this algebraically. But what you can do is you could solve graphically, right? So you could graph. So here's how we're going to graph it. I'm going to go to Desmos. I'm going to say y equals parentheses -9 out of 100. Remember I said be OCD with the parentheses because order of operations what the calculator does, or Desmos plus 9. The next one, you could copy and paste just to make your life easier, right? That'll be -6 out of 144. X minus 12 squared plus 6. Okay, clearly intersect at the origin. That's duh, right? But I have to intersect elsewhere too. Let me clear the screen because I don't need all that stuff there. So you just zoom out, and guess what? That's where they intersect. So they intersect about 16.55 feet away from where they threw the food items. And the guy is 5.137 feet tall. So there we go. That's his height. So he's 5 feet tall and some change. If you want to be a little bit more explicit about his height, you can convert that to inches, right? If you point, how many inches to a foot, guys? 12. So you just do that. Let me get my calculator. So if you want to be a little more explicit. So it's not hard. It's kind of a cool problem, I guess. About 1.64. It's a pretty short dude. 5 feet. Maybe this is middle school. He has a growth spurt afterwards. I don't know. So 5 feet, 1.644 inches tall. So, okay. Again, a little bit long-winded with the word problem, but realize you're dealing with a parabola. Use vertex form. And then in the context, hey, the food meets the same target, so you try to find where they intersect. Okay. All right, let's keep going, guys. One more page. All right. I'm gonna set it up. I'm gonna have you guys solve, and then 449. I'm gonna have you guys just do it all on your own or in your table group. Okay, so 448. Right, so this equation fits the situation below, then solve. Let's just solve it using the main strategies you can. Honestly, just solve it the way you're comfortable. So really, I don't care for this so much. As many as you can. Choose a method you're comfortable with. Okay, let's take a look at the setup here. Your math class wants to collect money for guys. Quiet, please. Thanks. your math class wants to collect money for a field trip, so it decides to sell 2 kinds of candy bags. The chocolate lovers bag costs $4.25 for 5 chocolate truffles and 2 caramel turtle candies. The combusting caramel bag, $3.50 for 8 caramel turtle cans and 2 chocolate truffles. So it's kind of reversed. How much does each chocolate truffle and caramel turtle candy cost? Okay. There are 2 things we don't know. Do we know how much it costs for chocolate truffle? No. Do you know how much it costs for caramel turtle candy? No. So I'm going to let X be very explicit with the way you let X equal. Let X equal the cost of each chocolate truffle. You can use different letters if you want, totally up to you. And let Y equal the cost of each caramel turtle. It's actually one of my least favorite candies. I like truffles better. Okay, so you have your variables, right? It's the cost of each. Now let's make equations. The first equation, I'll call this equation 1. And I'll call this equation 2. Equation 1. How many truffles are we talking about, equation 1? Chocolate truffles. 5. So 5x. How many caramels are we talking about here? 2. And what's the total cost of all that? Boom, got it. Second equation. The caramel bag, right? How many caramel turtle cans are we talking about here? But you got to put as Y though, right? Keep that in mind. Chocolate truffles is 2, and the cost is $3.50. Go and solve it. In your table groups, go and solve it. You can do substitution, you can do elimination. I don't care how you do it. Just solve it. Do whatever you're comfortable with. And by the way, will the answers be whole numbers? They should be, right? They should be whole numbers. Oh, sorry, no, I lied. Sorry. No. They could be decimals. Yeah, sorry, because cost. It's not number of items. Sorry. Erase what I just said. My bad. They could be decimals. There you go. They could be decimals. Go and solve it. Gonna freeze my screen and do it myself.
Oh, okay, yeah.
Yes, you got it. Yep, you got it. So if you solve it by elimination, maybe you multiply the top equation by -2 and divide by 5, or multiply the top by -4. Up to you. I cheated and I went to Desmos, or I took the easy way out. I graphed it. You can see they touch right there. I put each equation. The nice thing about Desmos, you don't have to isolate Y. You just type any way the equation looks, and it just does it. So Desmos is really awesome that way. And yeah, you find the point of intersection, right? It's super easy. But algebraically, what I probably would do, my recommendation would be to maybe multiply top equation by -4. If you do that, you get -20x, -8y. Using a calculator, you get -17. Add them up, you get -18x equals, -13.5. X should equal 0.75 if you do that correctly. And then you can solve for y by plugging into the equation, and you should get y equals 0.25. So that's all. Okay, we're good on that one. That makes sense? Yes? Good. Okay, guys, try the last one, and then we'll start the homework after that. Try the last one here. I'm gonna work it out too. I'll freeze the screen. I'll walk around to see if you guys are on the right track. So I'll do it quickly. Kind of, yeah. Kind of. Yeah. Oh, job B will be, guys, job B will be exponential. Job A is linear. Job A is linear. Let X be the number of years, guys. Let X be the number of years. Let Y equal the salary. And guys, use a graph. So someone may want to get a device out and use Desmos, or you could use a graph calculator.
I think we're no 14.
Yeah, give me a sec. I'm trying to figure this out on my own. Hold on.
Yeah, I think history we're too advanced. History we found 14 years.
They could intersect there, but there should be another point of intersection. But they could intersect there.
Literally divided. It never intersects.
After E.
At what?
Write the equation for part for job.
Hold on. Give me a sec, guys.
Intersection 7,000.
7,000?
Yeah.
Exactly 7,000.
Okay. I'll show you what I just did in a sec.
15, negative 15, 7,000.
I think I agree. It is 15 years in the past, actually. That's makes sense.
Hold on, I'll help you guys in a sec. Okay. Yes.
Okay. Yeah, graph is really tough. It's so much trash. Yeah, exactly. And then maybe go to like say 20 years. Yeah.
Yeah, boys.
No. I want to be ready to Europe. And then for the step, I make a step.
All my games are all on. The worst person is harder in souls, but most of the time I put it back. Yeah, it's. I mean, not bad.
No, I'm stuck.
I don't think I took that.
Oh, yeah, that's that. First one.
All right, guys. Let me show I got the answer. And then you guys can start the homework. Okay. So yeah, you need to go. Why? Okay, yeah, just get back. Yeah, you're good. All right. All right. So, guys, the equations. Let's wrap this up. You guys could get head start homework. So, job, guys, quiet, please. Yeah, yes, job A is a better choice initially because you start with more money, but then job B eventually will surpass job A. So, job A is just 3,000x plus 52,000 because you start with 2,000, you grow by 3,000 every year. So it's a linear equation, it's slope of 3,000. For job B, we're starting at 36, but it's exponential growth. Remember, 1 plus R is the base for exponential growth. The R is 0.11, so 11%. I haven't taught you guys how to solve something like this algebraically. In fact, actually, I think this is possible algebraically. So this would be a graph and calculator question, right? The problem is that these numbers are really large. So doing the graph and calculator is a little tricky. But this is the graph I generated in Desmos. See the lines right here, the curves right there, they touch. But that's what we look for, they touch. That's the solution. X is the number of years where they're the same amount. So anything less than that X value, job A is better. Anything more than that X amount, job B is better. Where do they meet? They meet at roughly $71,876. It's not roughly $72,000, but being more precise, $71,876.17. How do you do this in Desmos? Because if you punch them in, sometimes you don't see anything. It's really weird on Desmos. So how do I make this look so nice, right? Well, let me clear my screen so you guys see a little better. And let me just deliberately kind of just mess this up a little bit.
I can graph it in a graph calculator.
Okay, let's say you have something like this here, right? You don't see the equations, right? Or let me actually reset it. Here, let me just reset. Yes, go ahead. We'll talk about that tomorrow. Don't worry about it for now. Just use Desmos for now. Okay, actually, let me clear up one more time. It's being stupid. Here we go. Okay, I don't see the graph right now, right? I'd have to zoom out. It looks like it's a vertical line. So it's kind of weird, right? Let's do this next one. 36,000, 1.11 raised to the x power. Okay. I don't see that one either. But apparently it's there, right? And where are they going to touch? Probably maybe after 8 years or 10 years or 12 years. I don't know. So, guys, I need you to pay attention. So this is what you have to do. You have to fix the window. If you hit the little toolbar here, look at the minimum x value. Are we going to have negative 167 years? No. what's the first year I'm gonna look at? Year 0. So make that 0. Now, are you gonna work for 360 years? No, right? You don't live that long. Maybe we'll do like 10. And we'll make the step 1, so that way it's every 1 unit we see a tick mark. Okay, why is the money? Do you make negative money? No. We'll do 0 salary. Do you make $178? No, you can't live off $178 a year. Let's go $80,000. And let's make the step 10,000. There you go. Now you can see it, and there's the answer. So you have to get good at adjusting the windows. There's a way you can do it in the graphing calculator. I'll say that for tomorrow to show you guys how to do that. But adjusting the window is huge because now you can see it better. And so clearly job A is better when it's less than 6.625, but job B is better when it's more than 6.625. So that's that word problem. Okay. Homework's right there. If you want to get a head start, you can. We still have another 12 minutes of class. All the problems are right there. You can do it on the worksheet itself. So get a head start, jump around a little bit if you need to. Okay.